Okay, with the knowledge that you just learned about the Q of the surroundings being equal to the opposite Q of the system, we are going to apply the equation that we looked at, or that you had for homework, and that is this. Q equals M times C times delta T, where Q, of course, is the energy, and then everything else is just a rearrangement of the equation we had yesterday, where we have M, capital C, and delta T on the same side. And this will tell us the energy that is exchanged in any situation. And the situation that we're going to use is a closed container, closed environment called a calorimeter. And this is going to be an apparatus with a thermometer inside a insulated tube or insulated container, and within that we are going to put a certain amount of water, and that water we're going to consider the surroundings. And because the container is insulated and we keep any heat from escaping, then all the heat that is exchanged within the calorimeter should be captured and registered on this thermometer. And so what we end up having, get rid of these arrows, is we have a system that anything, whether it be solid that turns to liquid, whether it be a solid that is just hot, like a rock or something, we put in the calorimeter. It could be two things that we put together and there's a reaction that happens, an acid and a base. It can be anything that gives off heat or takes in heat. It could be an ice cube. And so we take our system, as you see here, and put it into the calorimeter. And what we're going to observe happen is we're going to observe what happens to the water. And so we have an initial temperature and then a final temperature of the water. And if we know how much water we have, then we can find out the energy exchange. Now you see down here at the bottom that I determined I had 100 milliliters of water. Because of density, 1 milliliter of water is equal to 1 gram of water. So if I have 100 milliliters of water, then I have 100 grams of water. That is the M for my Q equals equation. So you'll notice here I have 100 grams M times 4.18 joules per gram degrees C. We are going to use this number over and over and over again. And so anytime that you need C for today, you're going to use that number, 4.18. Now the change in temperature, delta T, we had from before, or we registered on our thermometer right here, the final and initial temperature, the initial and final temperature, excuse me. And to calculate delta T from now on, we are going to take final temperature minus initial temperature. Anytime you calculate delta T from now on, you're going to do final temperature minus initial temperature. And if I do that here, I get 70 degrees minus 20 degrees C, and that is 50 degrees Celsius. If I calculate that all together, I get Q of the water being 20,900 joules. That is the heat that is exchanged to the surroundings.